aluminum chlorate reacts with lithium sulfate. First step is to get your chemical formulas from your equation. So AI parentheses ClO3 parentheses 3 plus, because it reacts with Li2SO4, which is lithium sulfate. So we got the charges from the periodic table of ions, and what you would do is you'd see that it's a double replacement reaction because you have two. So that's a double replacement reaction. So PR. And so you do positive with negative, and because these are equal, they're balanced out, they're neutral, and these aren't, you'd switch their subscripts. So this gets the 2 and this gets the 3. Now you're gonna write your prediction. So it's aluminum with the subscript of 2 with SO4 because of the reaction. And then 3, because that stays, that doesn't switch, plus Li parentheses ClO3, which is chlorate, again because of the reaction.
Okay, so now we're going to take inventory. So we have on this side we have 1, 2, 2, 3, 2, 1, 3, 1. And now we're going to be doing the math to balance them out and make sure that all of these numbers are equal. So just to start, we are making this Al2 by putting a 2 on this side. So now these two are balanced. So now we have all of these balanced, and just to go over how we did it is we added our 2, which I already mentioned, and that 2 transfers to the Al, making it 2, and then it transfers here to the ClO3, making it 6. So that matches this, and then to match the ClO3 and make it 6 here, we added a 6 right here, which also transfers to the Li. So we have 6, 6, and then since the 3 was put here, it goes to the... So the SO4 on this side was already 3, and then since we added the 3 right here, this became 3, balancing those two out, and then that's pretty much how we balanced it. It was just adding these numbers, and then for the people watching at home, if you want to distribute it to check the work, all of it will balance out on this side. So this is our final answer. We have the 2 in front here, 3 in front here, and then we have 6 here, and then these are the balanced numbers.
Okay, so first we rewrite our balanced equation. 2 aluminum chloride plus 3 lithium sulfate. And that yields to aluminum sulfate plus lithium chloride. Chlorate, sorry. And that's not a 2, that is a 3. Okay, so now we read how many moles of aluminum sulfate are produced in a complete reaction of 0.37 mole of lithium sulfate. Okay, so I'm going to color code aluminum sulfate with red and lithium sulfate with blue. And we're looking for moles of aluminum sulfate. Okay, now that I know what we're looking for and what they give us, we're going to start off with what they gave us. So 0.367 mole of lithium sulfate. But first we need to set up our fraction. So we know that the problem is asking for lithium sulfate and aluminum sulfate, and we have those in our balanced equation, which are the one underlined in blue and underlined in red. So now we begin to set up our fraction. So number 1, it could either be lithium sulfate over aluminum sulfate. Or number 2, aluminum sulfate over lithium sulfate. Okay, so those are the 2 fractions that we can use for our train tracks later. So we're gonna start with the 0.367 mole of lithium sulfate, and we're just gonna highlight that. That's what we're gonna start with for our train tracks. Right, 2.367 mole of lithium sulfate. Okay, now once we know, we started with what was given to us in the problem. Just underline that real quick. Okay, so looking back at our fractions, we know lithium sulfate is at the top, and we need 1 at the bottom to cancel. So looking at the fractions, I wrote down number 2 as aluminum sulfate over lithium sulfate, and so number 2 is the one we're going to go with because lithium sulfate is at the bottom, and we're actually trying to look for aluminum sulfate, so it makes sense for it to be at the top. So number 2. Okay, so 1 mole of aluminum sulfate, which I have color-coded in red, and in the bottom we have 3 mole of lithium sulfate, which is what's gonna make the 0.367 mole lithium sulfate cancel, so that we could just be left with aluminum sulfate. Oh, and I forgot to add the 2 on lithium, so I just added it there. Okay, now once we have this all set up, what you do now is multiply across and then divide. So you're multiplying 0.367 times 1, and you're dividing that by 3, which will result to, before that, like I mentioned before, it cancels. So that's why you're only left with aluminum sulfate. But now that you know that, that leads to 0.1122333. However, we're not done. We still need to find the significant figures. So since our the original number that it gave us has 4 significant figures, ours have to have 4 significant figures too. So this one has, so 0.367. The 0 counts because of the decimal point. And now here, it'd be 1, 2, 3, 4. You could cancel the 3's. And you are left with 0.122 mole of aluminum sulfate. And box the final answer. And that's how you answer B.
Hello, I'm going to be answering question 3, part C. The question is, how many moles of lithium sulfate are used up when 29.10 grams of aluminum chloride react? So we will start off with putting the grams into moles, like I have written down here. So then we'll start off with 29.10 grams aluminum chloride, and we're going to put on the train track, and right next to it we're going to have 1 mole aluminum chloride, and under it we will have the atomic weight. The reason we will have it in grams is because we will want to cancel these 2 grams. Cancel just grams overall. So the way that we got the atomic weight is that we know that there's 1 aluminum, and we're gonna have to put this 3 that's outside of the parentheses, plug it into the element. So we have 3 chlorides, and then oxygen is gonna be, since it has a 3 right next to it, it's gonna be 3 times 3, so there's oxygen 9. So and if we go down here, we have the aluminum, which is 26.981539. We got chloride 3, which 1 chloride is 35.453, and we're going to do times 3, which gives us 106.359. Now we have oxygen, which 1 oxygen is 15.999, and we're going to multiply it by 9 since we do have 9 oxygens, which will give us 143.991. And overall, we just add all of these, and we get 277.331539 grams aluminum chloride. So then, now that we have grams turned into moles and we have canceled the grams, we want to turn the moles into molar ratio. So right here we would have 3 mole lithium sulfate, and under it we will have 2 mole aluminum chloride. And the reason why we have the 3 and the 2 is because if we look at our reactants, we have the 3 and the 2s here also. So we're putting the aluminum chloride specifically down here so that we could cancel these. So then now that we have this, we're going to use the top of our train track, these numbers, or these elements, and we're going to have to multiply them. So then we will get 87.3, and we're going to do the same thing with the bottom of the train track. We're going to multiply these two, and we're getting 554.663078, and we're dividing them, which will give us 0.153, sorry, 0.15739285, and we're gonna have to use sig figs, which we're going back to the beginning, which is 29.10 grams, and there's 4 sig figs. So then if we go back down here, we will get 0.1574 as our moles of lithium sulfate. Thank you.